Okay, hi guys. So in preparation for the second project, I wanted to give you guys this LTSpice tutorial. And some of the files, hopefully the Spice file and the project description will be up in Blackboard by the time you guys see this. But anyhow, this is primarily to get us started on LTSpice. And you're welcome to use any other type of spice like PSpice, something like that for this project. But I run a Mac, and what I was only able to find that's free and runs on a Mac and a PC is LTSpice from, I think it's from Linear Technology or Analog Devices, sorry, which is one of my favorite companies, by the way. But anyway, so here it is. Let's try to, I'll go through a couple of things that will be important for your, the second project. Okay, so I'm gonna start a new blank schematic. And it's kind of a pretty bare bones thing here, the interface. But on the Mac, you just sort of right click and you, let's say I want to lay down, I'm just going to make an inverter here. So I'm going to go find a NMOS 4, drop it down, and then I'm going to right click again, drop a PMOS 04. There we go, PMOS 4. Drop that down, and then let's see, I'm going to draw some wires between these guys. Again, a simple inverter. Let's see, draw a wire. Hopefully you guys are, I'm still trying to get used to this interface, so hopefully I won't have too many false starts here, but I'm sure you guys are gonna get a hang of this fairly quick. Okay, and then let's draw another line just because we're gonna make a connection to ports. So, and then another one here. Let's see. Okay. All right. So now we got our transistors in there, and now I'm going to add some ports so we can use this, make this into a symbol, and then use it in other schematics. So let's see, I go to net name, and this net name, what you do is you go to the port. So let's say I'm going to call the say in, port is an input, and I'm going to hit OK, shows up. Okay, and let's see, we need a output, ouch. Okay. And then let's put in VDD and ground. So VDD, and the port is bidirectional, goes up here. Go. And then let's drop in a ground. Or usually I call grounds VSS, so for source. Okay, so far so good. We have this the schematic for an inverter. Now we've got to link it to the right model name. I sort of found these TSMC 180 nanometer model name files. I'll put this on the blackboard, but you're going to have to, this is the name of the NMOS model, TSMC 180 in this thing, TSMC 180 nanometer P for the PMOS model. So we just have to make sure these guys are pointing to the right model. So let's see if I can just do this. Okay, and then I'm going to put in a default length of 200 nanometer, default width of 300 nanometer. I'm going to leave the drain area, source area, drain perimeter, source perimeter for you guys to fill out, but you'll have to do it for the project. You just have to sort of calculate what the drain, source areas, etc. would be. Because we're going to be changing, this is be one of those sizing things where you're sizing up and putting different layers of these things. So we need to parameterize the number of devices, so it'll allow us to do that later easily. So I'm just going to call the squiggly brackets, or what means you can do a parametric. So mn ends up being a variable that then we can put in as a parameter. Okay, and you can do it for the rest of these things too, the length, the width, and so on. But anyway, let's do that. Hit OK, and then we want to basically put the PMOS model here. Okay, at the PMOS, the length is also 200 nanometers. If you guys, make sure you worry about the spacing on these things. Like this, if you put this 300 space NM, I think it tends to get confused. So be careful with that. Took me a while to debug some of these things. So the number of parallel devices for the PMOS, I'm going to parameterize that as MP. Okay. All right. Okay, so we got this now. Now we need to put in a default parameter for both of those, so it doesn't go haywire if somebody doesn't add a parameter. And we want to create a SPICE directive. So we can basically type in whatever we want that are SPICE commands. And anyway, what I'm going to put in there is a param command. Mn is equal to, so the multiplier for n, I'm going to make 1, and multiplier for p, I'm going to make 2. So that's the default. Okay, and it kind of just shows up here in the corner. Okay, so let's save this. Let's see, and then from here, I'm gonna create the symbol so I can drop this into a higher level in the hierarchy. So I'm gonna say open the sheet symbol, and it's gonna say I couldn't find the sheet symbol. Shall I automatically generate one? I'm gonna say yes. Okay, and here's our default symbol. Of course, again, it doesn't look like anything sensible. I'll leave it up to you guys whether you want to make this looking clean or something that represents the symbol, or just use a box. I'm gonna take a quick shot at. It's I gotta admit it's not easy to make the changes to the symbol, but let's try it. Let's try to make the symbol here. So I'm gonna delete this guy, and I'm gonna move some of these guys around so that it's easier for us to. Whoops, no, out should be kind of out here. VDD should be up here. VSS should be down here. And then let's see, I want to put out facing out from the pin and the in. I'm just right clicking on these things here, facing that way, and then I want this guy facing, seems like it's going sort of reverse of what you would think, but anyway, right clicking, top, okay. So those are spaced roughly where I think where I want them. And then I'm gonna draw, let's see, let's try drawing a rectangle, or sorry, a triangle. And go up to, I don't know, let's say here. And then that was 3 down. Let's try to do it. Same thing here. And connect them up here. And then drawing a circle is not easy, so let me try that. Circle wasn't easy for me anyway. Let's see, something like that. Hey, it kind of worked. Okay, and then I'm gonna move this over here. Oops. How do I move? Come on, cooperate, buddy. Move. Okay, so now I'm gonna just again move these things around where I want them. So this guy out here, maybe move it in a little closer, and BDD and BSS over here. Yeah, that looks good. Okay, and then I'm gonna just draw some lines. I think these are just cosmetic here, but again, oops. Okay, undo. Oh no. As you guys can tell, I haven't gotten a hold of, I haven't gotten used to do this drawing business here. That's probably been the toughest one. Whoops, that didn't work. Let's try that again. Okay, anyway, I'm gonna call this good. Not worried about too much about the aesthetics. Again, I'll leave this up to you guys to see if you guys wanted to just keep it as a rectangle or whatever is easier for you guys. Okay guys, so now we want to use the schematic that we just made. So I'm going to start a new blank schematic. Okay. Now, for whatever reason on the Mac anyway, if I try to put a component down without saving the location of this, it only goes to this top directory. There's ways to change this in the PC version, but I haven't been able to change the Mac set in the Mac version. So anyway, what I just did that fixed it or allowed me to get the right path is I saved this in the same directory that I had put the basic inverter in. So I'm going to call this scaling. Let's say driver scaling. I don't know, driver scaling in the desktop. Okay. Now I should be able to drop in my component that I just created. So point at the desktop, I call this thing inv. Okay, then I want to drop this guy in, and I want to drop 2 of them in, just to try a couple of things. Okay, so now I got the inverters in here that I just created. Now let's try to do some sims. So we need some voltage sources. So put in some, let's see, should be here somewhere, voltage source. Okay. We need something for the VDDs. I'm going to just keep them separate. And then something for the inputs. I might end up needing to just copy those, but anyway. Okay, so let's say the VDD, I'm just going to have a 1.8 volt and no DC series resistance. Let me just move these guys here. Give ourselves a little bit of room. Okay. All right, and then I am going to, so to put the ground in, you gotta create a net and then make it a ground. Okay, so that then shows up as this guy here. And then I'm going to wire that up. Power that dude up. I'm going to drop in, so let's just copy this stuff. Maybe it's easier. Duplicate. Oh, that's not what I wanted to duplicate. That didn't help. Okay. Come on. Okay. Might as well throw one here. Might as well throw one here. While we're at it. Throw one here too. Oops. Okay. All right. So let's draw a wire. I'm gonna have this as the input. And the ground on this guy. Okay. Wire. Okay, so we had a double click on that and get 1.8 volts. Okay, that's good. Double click on that. So this is going to be a transient input, means that we'll create pulses that go up and down. So you have to hit advanced, and then you get a bunch of options. So I'm just going to make this pulse. So typically for transient analysis like we're in, so we're not doing analog design, usually either use a pulse or a piecewise linear. Right now I'm just going to use a pulse. Initial value of the pulse, this is the voltage, is 0. The on voltage of the pulse is 1.8 volts. The pulse will start a nanosecond into the simulation. Let's give it a fast rise time, I don't know, 50 picoseconds. Fall time is the same, 50 picosecond. It's going to stay on for 2 nanoseconds, and every 4 nanosecond it's going to repeat. And then I'm just going to have it repeat indefinitely. And you can add other things there. So anyway, but let's start with there. And it puts the what it's doing over here. Okay, so now let's also give this thing a load. So a capacitor. Okay, there we go. And this capacitor is going to get wired up top. We're going to be driving it with this guy. And then that's good. And then we got to give a capacitor a value. let's see, parallel capacitance. Let's call it 10 femtofarads. Hopefully it'll like that. Okay. All right, so that's 10 times 10 to minus 50. Okay. So let me actually delete this thing first. Let me just keep it simple and start with one thing. Okay, so I'm going to delete this guy. So now we're almost set up, but we need a couple more things. We need to put in the models. Okay, so here what you do is you do let's see, do the spice directive thing. Okay, and I'm just going to go to this text file, and then I'm going to select all, copy it, and then dump it down here. So that's my model file. Okay, that's the spice model. Okay, so then the other thing we need to do is to put in our transient simulation. So let's do another spice directive. Let's see, where is it? Spice directive. Okay, and then I'm going to do a .tran for a transient simulation. I think the first thing is the steps. So let's say I'm going to go 10 picosteps, and then I'm going to have it run for, say, 10 nanoseconds. Okay. So make sure you guys get these, like the N in the nano and the 10 in the pico and stuff. That's important. Otherwise, you're going to end up doing a 1 second simulation, and it's going to like sit there forever. Okay. So anyhow, let's try with this and see if it'll run. So I'm going to hit this guy, this running dude up here, see if this runs. Okay, it opened up a window. That's encouraging. And then I'm going to come back here. Let's do this. I'm going to have this guy be top half, and this guy be in the bottom half. Okay. And then basically when I'm here, you'll see a little probe thingy pop up. All right, guys, so I'm going to probe the input. You see it's staying 0 for 1 nanosecond, has a fast rise time, I think what it be 50 picoseconds or something, stays high for 2 nanosecond, and the entire thing repeats every 4 nanoseconds. Okay, so it starts again at 5 nanoseconds because we started at 1 nano. Okay, and then I'm going to poke at this guy, and you see it's inverting with some kind of a rise and fall time. Okay. Okay, so that's good. So now I'm going to, let's say I want to now increase this load a little bit. So let's say I want to make this, let's say 50 femtofarad. So again, make sure you have the F in here and don't put any spaces in between the 50 and the F or whatever capacitance you have. Otherwise, there'll be the thing is gonna not get it. So anyway, I'm going to simulate, and you see it slowed down. Okay, because the loading is now more. Okay, so the other thing we can do here, which we already set ourselves up for, is remember we had parameterized the multiplying factor in the transistors in the inverter. Okay, so I want to change the parameters here to increase rise and fall time, so I'm just going to make this parametric. So if you remember, we had the multiplier for the N and the multiplier for the P. I think they were, I can't remember if they were both. Well, I guess we can just look it up. So I should be able to open the schematic here. We had the P2 and the N1. So I'm going to go back. Nope, just close it up. Okay, so now I'm going to change this parameter. So Mn is equal to 5. So I'm going to have a 5 times bigger n and a 10 times minimum size p. So let's see, hopefully that took. And now I'm going to simulate. Yep, and you see it's sharpened up the rise fall times. Okay, so anyhow, this is the kind of stuff you'll need for the first project. There's a lot of good stuff in LTSpice. I like it. It's bare bones, but you know, I like that it's, you know, it's got a lot of stuff you can do to poke around in it. And anyhow, hope you guys have luck trying it out. And as usual, let me know if you got any issues. Take care. Bye.